Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing miscellaneous questions from law of chemical combination. Up to question number 30 I have discussed. Today I am going to start from question number 40. Questions are based on laws of chemical combination. Now question I am telling you, question number 40. Which one of the following pairs of substances illustrates the law of multiple proportions? Which one of the following pairs of substances illustrate the law of multiple proportions? First option is carbon monoxide and carbon dioxide. Second option is sodium chloride and sodium bromide. Third option is water and heavy water. And last option is option 4, magnesium oxide and magnesium hydroxide. Again I am reading the question. Which one of the following pairs of substances illustrate the law of multiple proportions? First option is carbon monoxide and carbon dioxide. Second option is sodium chloride and sodium bromide. Third option is water and heavy water. And fourth option is magnesium oxide and magnesium hydroxide. Think and answer. It will take only 30 seconds. Answer is option A. Answer is option A. In carbon monoxide and carbon dioxide, the two elements combining are C and O to form two compounds. Carbon monoxide and carbon dioxide, the two elements combining are carbon and oxygen to form two compounds. Okay, hence question number option A. Option A is correct. Now question number 41. Actually this question was question number 40. I am talking about which one of the following pairs of substances illustrate the law of multiple proportions. The first option was that which is correct, carbon monoxide and carbon dioxide. Okay, why? In carbon monoxide and carbon dioxide, the two elements combining are carbon and oxygen to form two compounds. Both are common. C in both compounds C is there, in both compound O is there. Okay, then question number 40, that is the option A is correct. In other option you will see, then one is sodium chloride, other is sodium bromide. Okay, and third option is water and heavy water. Both are different. Means this water and heavy water. And fourth option was magnesium oxide and magnesium hydroxide. not common. Water and heavy water. Water is H2O. H2O. Heavy water D2O. That is a differing. Mass number is differing. Okay. 1H1 and 1H2. That's why correct answer is first one, carbon monoxide and carbon dioxide. Next question, 41. Two metallic oxides contain 27.6% and 30.0% oxygen respectively. If the formula of the first oxide is M3O4, that of the second will be option 1 MO, option B MO2, option 3 M2O5, option 4 M2O3. Again I am telling the question. Two metallic oxides contains 27.6% and 30.0% oxygen respectively. If the formula of the first oxide is M3O4, that of the second will be, four option is there. First option MO, second option MO2, third option M2O5 and fourth option M2O3. Now you have to tell which one is correct. First oxide is M3O4. Then what will be the second? Now you think an answer. It will also not take more time. Hardly 1 minute. Hardly. Now you think an answer. I am telling you, in the first oxide, answer I am telling you, explanation. In the first oxide, oxygen percentage is 27.6 parts. Not oxygen, yes. Oxygen percentage is 27.6%, means parts you can tell. 27.6 parts. And then obviously metal will be 100 minus 27.6, that is 72.4 parts. In the second oxide, oxygen is 30%, means 30 part. Then out of 100, then metal will be, if oxide is 30, then metal will be 100 minus 30, that is the 70 parts. As first oxide is M3O4, first oxide is M3O4, then 72.4 parts of M, that is equal to 3 atoms. Correct? First oxide, oxygen is 27.6, then metal will be 100 minus 27.6, that is the 72.4 parts. In the second oxide, oxygen is 30%, then metal will be 100 minus 30, 70 parts. As first oxide is M3O4, it means 72.4 parts of M is equal to 3 atoms, because first oxide is M3O4. It means metal is 3, M is equal to 3 atoms. Correct? And 27.6 parts of oxygen, that is the 4 atoms of oxygen. M3O4 means metal is 3 atoms and oxygen is 4 atoms. Okay? Then now only on this basis you can calculate that 70 parts M means how much? 70 parts M means how much? 3 divided by 72.4 into 70 atoms of M. Correct? First oxide is M3O4. Then it means M3 means 3 atom of M. That is actually 72.4. 72.4. Then M and 27.6 parts of oxygen. That is equal to, oxygen means 4 atoms, M means 3 atoms. Then now you can easily calculate 70 parts. Second part you want to calculate. Then 70 parts of M is equal to 3 by 72.4 into 70 atoms. Okay, because in first case it was metal was 72.4. Then 72.4 means 3 atoms. Means 3 atoms. 72.4 parts. Metal means 3 atoms. Then 1 part means 3 by 72.4. Then 70 parts means you have to multiply by 70. Upside 70. Then you will get 2.9 atoms of M. Then 2.9 atoms of M you have calculated. That is 70 parts of M means 2.9 atoms of M. Now again you can see 30 part of oxygen. 30 part of oxygen is equal to 4 divided by 27.6 into 30. That is 4.35 atoms of oxygen. Then now metal you have calculated, oxygen you have calculated. 70 parts of M means 2.9 atom. 2.9 atoms of M. And 30 part of oxygen means 4.35 atoms of O. How you calculated oxygen atom? Then second option for this second oxide actually you want to calculate. Then first oxide is M3O4. That is the basis. In that oxygen is 3 atom, oxygen is 4 atom. Okay, only on that basis you are calculating. Then 30 part of oxygen, that is equal to 4 divided by 27.6 into 30. 30 will be upside. Then you will get 4.35 atoms of oxygen. Then ratio of M and O in the second oxide will be 2.9 is to 4 is 4.35. Means it will come on solving 1 is to 1.5. Then just to multiply by 2 both, then it will come 2 is to 3. Hence formula will be M2O3. Formula will be M2O3. Hence option is D. Correct option is D, M2O3. Okay, this is very good question. If you will apply this technique, then it will see quickly it can solve. You have to think that first oxide is given M3O4, and then second oxide they are asking to calculate. Then M is common, same metal is there, same oxygen is there, only percentage is differing. Hence you can calculate on what ratio both are in M3O4, on what ratio they are combined. Keeping in that way in mind, you can calculate ratio of M and O for second compound. Okay, then that will be M2O3. Okay, it will take less time only, because 27.6% is metal 30% is oxygen. It means 27.6 parts. That is the metal out of 100 parts. Correct? And oxygen is 30%. Then both you deduct from the 100. 100 minus 27.6. Then you will get these things, metal. And 100 minus 30, you will get oxygen. Correct? And after that, second you have to calculate. Then this 27.6 parts oxygen. In the first oxide, oxygen is 27.6 parts. Then metal will be 100 minus 27.6. That is a 72.4. Metal you got, metal parts. Then in the second oxide, oxygen is, according to the question, it is 30 part oxygen. Then metal will be 100 minus 30. That is the 70 part. Correct? Then now in second, how much oxygen is there, how much metal is there, now you are knowing. 30 parts oxygen, 70 part metal. Then now just to see the first oxide, M3O4. M3O4 means what? Metal atom is 3 and metal oxygen is 4. M3O4, metal is 3, oxygen is 4. Then here 3 atoms means 27.6. 3M means 27.6. Correct? M is equal to 3 atoms of M and 27.6 means oxygen is 4 atoms. Then this is important, M3O4 you have to consider. Then now you know that 72.4 parts metal means 3. 72.4 parts metal means 3 atoms. Then 70 parts you can calculate. If 72.4 parts means 3 atoms. Correct? Then 70 parts means how many atoms? Then it will be 2.9 atoms. Same way 30 part of oxygen. 30 part of oxygen, how much it will get? Then you know that 27.6 6 parts of oxygen. That means 4 atom. 27.6 parts of oxygen means 4 atom of oxygen. Then 30 parts means 30 part of oxygen means 4 divided by 27.6 into 30, upside 30 atom means after solving you will get 4.35 atoms of oxygen. Then what are the ratio of M and O? Then 2:9 at 2.9 is to 4.35. If you will solve it, you will get 1:1.5. Then now multiply both sides by 2. Then you will get 2:3. Hence the answer will be M2O3. This question is very, very important for advance. IIT advance, for that this question is fit for them. Now next question I am telling you. Question number 42. 1 liter of N2. 1 liter of N2 means nitrogen gas combines with 3 liter of H2 to form 2 liter of ammonia gas NH3 under the same condition. This illustrates, 4 options are there. First option is telling law of constant composition. Second option is law of multiple proportion. Third option is law of reciprocal proportions. And fourth option is Gay-Lussac's law of gaseous volume. Think in less than 30 seconds it requires. Again, I am reading the question. 1 liter of N2 means nitrogen gas combines with 3 liter of H2 hydrogen gas to form 2 liter of NH3 means ammonia gas under the same condition. This illustrates the first 4 options are there. First option is law of constant composition. Second is law of multiple proportions. Third is law of reciprocal proportions. Fourth option is Gay-Lussac's law of gaseous volumes. Then you tell me answer. It will take 10 seconds if you are knowing. Answer is option D. Gay-Lussac's law of gaseous volume. N2 plus 3H2 that is equal to 2H3. Okay. This is it is following Gay-Lussac's law of gaseous volume. Okay. Then now the ratio of volume of N2 H2 NH3 is 1:3:2, which is a simple ratio. This proves Gay-Lussac's law of gaseous volume. Next question I am telling you, question number 44. Question number 43. Question number 43. 12 gram carbon combines. 12 gram carbon combines with 64 gram sulfur to form CS2 means carbon disulfide. 12 gram carbon also combines with 32 gram oxygen O2 to form CO2. 10 gram of sulfur combines with 10 gram of oxygen to form SO2 sulfur dioxide. Again you listen the question. 3 reactions are there. First reaction, that is a 12 gram carbon combines with 64 gram sulfur to give CS2. This is the first reaction. Second reaction, 12 gram carbon also combines with 32 gram oxygen to form CO2. Third reaction, 10 gram sulfur combines with 10 gram oxygen to form SO2. These data illustrate the option. 4 options are there. First option is law of multiple proportions. Second option is law of definite proportions. Third option is law of reciprocal proportions. And fourth option is law of gaseous volumes. Just you answer. Think and answer. It will also take 30 seconds. Then again option I am telling you, law of multiple proportions, first option. Second option, law of definite proportions. Third option is law of reciprocal proportion. Fourth option is law of gaseous volumes. And question 3 reactions are there that I am telling you. 12 gram carbon combines with 64 gram sulfur to give carbon disulfide. Second is 12 gram, same 12 gram carbon also combined with 32 gram oxygen to form CO2. And third reaction is 10 gram sulfur combines with 10 gram oxygen to form SO2. Now you have to answer. Okay, 4 options already I told you. Correct answer is law of reciprocal proportion. That is the option is C, law of reciprocal proportion. 43, just you see, ratio of the question, already I told you, now explanation I am telling you. Ratio of the weight of sulfur and oxygen combines with a fixed weight. Ratio of the weights of sulfur and oxygen combining with fixed weight of carbon is 64:32. Correct? Ratio of the weights of sulfur and oxygen combining with fixed weight of carbon is 64:32. Sulfur weight 64, oxygen weight 32. That is the 2:1. Ratio of the weight of sulfur and oxygen combining directly, that is the 10:10. That is the 1:1. The two ratios, these two ratios are simple multiple of each other. This proves law of reciprocal proportion. Okay. First you have seen 64:32. That is the 2:1. And second is sulfur and oxygen combining directly. That is the 10:10. That is 1:1. Okay, 1:1. The two ratio are simple multiple of each other. First ratio was 2:1. Second is 1:1. Okay, these two ratios are simple multiple of each other. This proves law of reciprocal proportions. Okay. Now next question I am telling you, that is the question number 44. 44. Which one of the following represents Avogadro synthesis? Which one of the following represent Avogadro's hypothesis? Very easy question. 4 options are there. First is equal volume of all gases under same condition of temperature and pressure contains equal number of atoms. Second option is equal volume of all gases under same condition of temperature and pressure contain equal number of molecules. Third option is gases react together in volumes which bear the simple ratio to one another. This is the third option. Again, third option I am telling you, gases react together in volumes which bear a simple ratio to one another. And last option is the rate of diffusion of gases are inversely proportional to the square root of their densities. This is the fourth option. The rates of diffusion of gases are inversely proportional to the square root of their densities. Question is, which one of the following represent Avogadro hypothesis? This is very easy question. Then its correct answer is option B. Avogadro hypothesis, you remember, equal volume of all gases under same condition of temperature and pressure contain equal number of molecules. Okay, this is the definition of Avogadro's hypothesis. Hence option second, that is the equal volume of all gases under same condition of temperature and pressure contain equal number of molecules. Okay. Now next question I am telling you, that is the based on atoms and molecules, atomic mass, molecular mass, mole concept, and determination of chemical formula. Okay. Again I am telling you, now onward question will be based on atoms and molecules, atomic mass and molecular mass, mole concept and determination of chemical formula. Then all question will be based on that. Today at least one question I will take from this chapter. Question is atomic mass of an element. Atomic mass of an element. Option is given. Atomic mass of an element is, first option is the actual mass of one atom of the element. Second option is the relative mass of an atom of an element, relative mass. First option was the actual mass of an atom of the element. This was the first option. You have to tell atomic mass of an element. Then first option is the actual mass of one atom of the element. Second is the relative mass of an atom of the element. And third option is the average relative mass, the average relative mass of different atoms of the element. And fourth option is much different from the mass number of the element. This is the fourth option, much different from the mass number of the element. This also will take less than 30 seconds just to think and answer. Option is third option, C. Option C is correct, means the average relative mass of different atoms. Okay, the average relative mass of different atoms of the element is called atomic mass of an element. Okay, C is correct. C is based on definition of atomic mass. This is the actually definition. Okay, then now I have discussed questions. Today I am stopping only here, and next class again I will continue. Thank you.